This is a simple SAT question from the official practice test by the College Board. However, I think the solution that they provide for this question is too long, so I want to show you guys a faster way to do this. And this is also the last question of the practice test, and usually the last question is the hardest one, so let's take a look. We are going to find the sum of the solutions to this equation here. Well, first let's just do the usual business. Multiply in the x, we get x squared plus x. Keep the minus 56. Right here, multiply in the 4x. So we get 4x squared minus 28x. Now we have a quadratic equation because we have the x squared term. We need to make one side equal to 0, and let's make this side equal to 0. Subtract 4x squared to both sides. Cancel, cancel, and then add 28x to both sides. So cancel, cancel. And ladies and gentlemen, we have 1x squared minus 4x squared, which is negative 3x squared. 1x plus 28x, that's plus 29x. And then minus 56, and that's equal to 0. Now we have a quadratic equation in the standard form. You can try to factor it or use the quadratic formula, and you will get two answers for this equation. And then just go ahead and add them up because we are trying to find the sum of the solutions. But don't do that. That takes too long. And that's what the official solution did. Here's a much faster way. Check this out. If the question is asking you for the sum of the solutions, all we have to do is the following. Sum of the solutions of a quadratic equation whenever it's in the standard form. You start off by looking at the coefficient of x, which is 29. Go ahead and divide it by the coefficient of x squared, which is negative 3, and then negate the result. Negative, negative becomes positive, so we have positive 29 over 3, and we are done. Just like that. And if you would like to have a little bonus, if you are looking for the product of these solutions, again, just make sure that we have the equation in the standard form, then you do the following. Look at the constant term, which is negative 56, and then divide it by the coefficient of x squared, which is negative 3. And for this one though, we do not need to negate the result, just keep that. Both of them are negative, so we'll end up with positive 56 over 3. That would be the answer to the product of the solutions. Now, the idea behind this right here is called the Vieta's theorem, and let me give you guys a quick proof for that. Let's start off by looking at the equation in the standard form. Ax squared plus bx plus c is equal to 0. And because this is a quadratic equation, a is not equal to 0. Otherwise, we don't have that term. So look at this. We are going to divide everybody by a first. So we will get just x squared plus b over a, x, and then plus c over a, 0 over a, just 0. Now focus on this equation here. So imagine you can factor it. You will get x minus something times x minus something else, right? I'm going to call the something roots. I will still say R1 and R2. So I will just say let R1, R2 be the solutions. If I factor it successfully, then I will be able to get this into x minus R1 times x minus R2. In fact, it's always possible. It's just depending on if R1, R2 are real or complex. But it's always possible. Now, imagine if I factor this and get that. I want to figure out the sum of R1 and R2, and maybe the product of R1 and R2. Then we can do the following. Multiply this out then. X times x is x squared. X times negative R2 is minus R2x. This times that is negative R1x. Negative R1 times negative R2 is plus R1 R2, and that's equal to 0. Have a look right here. Both of these terms have x. Both of them are negative. I'm going to factor out the negative, and then you will get the following. R1 goes in here, becomes positive because we have the negative on the outside already. Negative R2, well, we just need to have positive R2 here because the negative is on the outside already. Both of them have the X. I will put the X on the outside here. And then we have the R1, R2 is equal to 0. Now, compare this equation with what we have right here. They have X squared, they match. Now, this is where we are going to get the R1 plus R2, which is for the sum. So, if you put this equal that, well, we will get negative R1 plus R2. This will be equal to B over A. Divide both sides by negative, then we see R1 plus R2 being equal to B divided by A, and then negate the result. That's exactly what we did. The sum of the solutions is equal to, here is the B from here. This right here is the A from here. So we have 29 over negative 3, and then we negate the result, and then we get that for the answer. That's just like right here. And as a little bonus, as I told you, if you have the product of the roots, R1 and R2, this must be equal to that, which is just C over A. And that's exactly what we did. The product of these solutions, this right here is the C, and this right here is the A. Just like that. So if you remember these little two formulas or these little two ways to do it, yeah, this kind of questions will be very fast. That's it.